Welcome! We are solving an orbital problem that involves graphs of energy. Here is the graph that you see for the Hubble Space Telescope versus its orbital radii with kinetic energy, total energy, and potential. The question that we're going to start with is this one here. And it's asking, Hubble's orbital radius right now is about 7 million meters. If you double that and put it at 14 million meters, it's going to speed up or slow down. Let's go back to the graph. Alright. Currently, the Hubble telescope is at about 7 million meters. So that's this radius. If we double it, put it out here at 14 million meters, that, first of all, would be probably a bad idea, because that is probably well beyond the zone that the space shuttle, if there were a space shuttle anymore, could probably no longer service it. But if we look at what happens to its energy, most importantly, put this on the pin. Most importantly, its kinetic energy at 7 million meters would be here, and that's at about 3.2 times 10 to the 12th joules. It's a lot of energy. If you move it out, its kinetic energy is going down to only about maybe 1.6 times 10 to the 12th joules. And that's actually sort of interesting, that if you double the orbital radius, you cut the kinetic energy in half. And so you should rationalize that if kinetic energy has been cut in half, and if kinetic energy is 1/2 mv squared, if you bring down the kinetic energy and the mass stays the same, then the velocity has to go down as well. So anything at a higher orbit will have slowed down. Next question is, we want to use the graph to figure out actually how fast the satellite would be going at this new radius of 14 million meters per second. So, look back at the graph. We just need to use the kinetic energy equation, which is pretty easy. That kinetic energy is equal to 1/2 mv squared. And then we rearrange and we solve for v, so we get this part here. Square root of everything. And then we plug in numbers. Our kinetic energy is the new, smaller one, 1.6. It's 10 to 11th joules. And we divide by the hefty mass of the Hubble, which is 11,000 kilograms. And then I'll calculate that in my head. And that turns out to be 5,400 meters per second. And just for comparison, earlier in this lesson we calculated the actual speed up here, and when it was this location it was going something like 7,600 meters per second. So as you move satellites out, they do get slower. So for the third question, as the Hubble is in its low Earth orbit, it will be colliding with a very small amount of molecules. And what will those molecules do to the orbit if you don't correct for it? Well, if we look at the graph, let's say the Hubble is at any particular orbit. Let's just say it's at this radii. It has a certain amount of kinetic energy. And if it's going to be hitting molecules, it's going to be bumping them out of the way and give them kinetic energy. So then its kinetic energy has to slow down. But if it slows down, the force of gravity that's pulling on it is going to be pulling on it just as strong, but it's not going fast enough to remain in a stable orbit. So it's going to fall a little bit closer since it slows down. So as that happens, its potential energy that was here, it might drop down to here, and the potential energy has become more negative. And what's happened to that potential energy? Well, that potential energy has become kinetic. So its kinetic energy has actually gone up. And so the funny thing is that as it gets slowed down, it then gets pulled inwards, and that pulling inwards speeds it up. But now it's at a closer orbit. And now the atmosphere of the Earth is a little bit more dense. So that means it's hitting more molecules. It's kicking more molecules out of the way, and so it loses even more kinetic energy, and it slows down, and then it gets pulled even closer in to the planet. And as it gets even closer into the planet, it's going to be falling down here, and then its kinetic energy's gone up again. And so it speeds up, and then it hits even more molecules and falls in, and it speeds up more. So the ironic thing is even though it's losing kinetic energy as it hits more molecules, it's always falling inwards and always speeding up. So if satellites decay in their orbit, they will spiral inwards, but they will speed up as they come in. They're hitting more stuff, and so bad things start to happen very quickly unless satellites' orbits are stabilized with small thrusters or whatever it takes to keep them in their orbit. That's it. Woo!